Then we have this third region, and this third region where you can see the distribution of earthquake differently in terms of their formation, differently in terms of their interaction. I hope you remember the very first is this Circum-Pacific belt. It is different as that of the other kind of belt. It is different here. The subduction is, as the subduction is taking place between the continental and oceanic plate, volcanism is there, earthquake is there. If you have focused on the second part, that is the Alpine-Himalayan belt, here we have a continental-continental convergence. Volcanism is not there. Volcanism is not well appeared as that of Pacific, of fire as that of Pacific convergence, which is place. So that's why here you will not see volcanism, you will see earthquake. And as the volcanism is not there, the subduction zone is not there, earthquakes are not that much frequent as compared to the frequency which is there in the Pacific. So here they are not frequent. It's because of the continental convergence. Volcanism is not there. So only the plate will going to shake. There will be vibration. Third one is different, categorically different as that of the rest of the two. And the third one is mid-oceanic or mid-Atlantic ridges. This mid-oceanic or mid-Atlantic ridges or mid-Atlantic belt, it is along with the mid-oceanic ridge at the bottom of Atlantic Ocean, and about 5 to 7% of earthquake which are taking place globally, they are actually observed here. These earthquakes are mostly shallow focus earthquake, and they are less destructive because at the depth they are there. Second thing is there is a gentle flow of magma or lava on the surface. As a result of this, the earthquake which are there, they are comparatively lighter. They are not that much destructive as that. Wherever the subduction is there, violent earthquake. So when we have a volcanoes, that is like a fire, that's why the name is given accordingly, Pacific of fire, volcanism. They are associated with a divergent plate boundary, means the seafloor is spreading ice. So here the convergence is taking place with respect to the continental and oceanic. Here the convergence is taking place with respect to the continental. Here the divergence is taking place with respect to the different places. Could be oceanic to oceanic, continental, primarily continental. Okay, we have this kind of divergence, mid-oceanic ridges, that is the third belt where you. Then we have a very rare kind of event, that is the intraplate earthquake. So even in the plate itself we can have an earthquake. As of now, we discussed in the previous session, I hope you can relate that with the edge, along the edge there will be earthquake, but apart from the edge we can have an earthquake which is locating is actually locating is actually locating away from the edge. So at the edge there might be a convergence, there might be a divergence, because of which there is a shaking. At the mid, or let's say intraplate, is happening, fault first. Fault will have what? So earthquake that occurs within the interior of tectonic plate, away from the plate boundaries, that occur with the tectonic plate, not at their, much less. They are much less frequent than the interplate, or let's say on the edge plate earthquake, very less frequent. And these intraplate earthquake occurs along the basically weak or reactive faults. Okay, and we have an earthquake in India, Bhuj, Gujarat. Remember, I was in school in that point, and there was for that date was next day news translation Bhuj. So scientists or geographers state that there are Bhuj is very much away from the Himalayan region, edge of Indian plate. Then I give Himalaya is the young cold mountain. found because of the convergence of India that of both are the continent. So if there is a continent at the edge, earthquake are likely. Why the Bhuj have a distance? Why Bhuj? It is because its proximity fault, as it is located near to the fault. By third, okay. So I hope now you can relate that earthquake will take edge for sure. Yes, intraplate also will intraplate narrowly. Going ahead, here you can see intraplate earthquakes. Specifically, if you see with respect to the intraplate, for instance, the earthquake at the along with apart from the rest of them, rest of them, they are basically the edge. They are basically so typically they are likely to okay, intraplate as well. Don't have any plate margin. Here you will see how these kind of rift valley did this, and here we have a continental divergence. It is actually rift valley is forming in Africa. So this is how we have, or let's say, intraplate. Why? Because apart from the now here you can see the plate. Here, these are the earthquakes. These are the earthquake, and now you just superimpose this on this plate. Then you will have a more hope there is a clarity that along the plate edge. This is how the plates are being distributed. Similarly, what kind of earthquake? Similarly, superimpose. Now, in order to measure the earthquake, seismograph is actually used, and seismograph is basically that we're going to detect and record. That is going to detect and record what vibrations which are actually produced by the seism. You might have seen in movies, you might have seen in television that there is one paper, and on that particular paper there is the one needle put on, and whenever there is a shaking, there is a needle which is. So that pattern is basically what. Okay. Now, with respect to the seismograph, when we have a reading, whether the reading is devastating or not, or to what extent damage. So, in order to have that particular idea, we have a two set of a Richter scale and we have a Mercalli scale, and we have what Mercalli scale. So, Richter scale is there, which will going to measure the magnitude. Energy is released. This Richter scale will going to measure what? This energy actually released. It will going to measure the magnitude. I would. Whereas if you see Mercalli, so Mercalli will going to measure the intensity, that to what extent there will be a damage. Okay, this Richter scale will going to measure the energy which is released, whereas the Mercalli will going to release that to what extent there is damage. In Richter scale, the instrument is based on quantitative, that to what extent the energy is released. But here, Mercalli, it is observation based and it is qualitative basically. In Mercalli, like the value varies with the location fact. Use that varies significantly. With respect to the location and impact both. Here, see this scale value is same everywhere. I mean the energy which is there, so that energy is being observed in the same manner. So it's same. Whereas in the Mercalli, the location, the value used to vary. The scale which is there, so 0 to 10 is the reactive one, and yes, 1 to 12 in Mercalli. So both of these damage energy, which this is for the geographical purposes, for seismic studies, basically for the disaster management, to what or okay. So in this way, ahead. Let's have a question. So just read this question and this asked friends. Read this question. Consider the following statement. In a seismograph, P waves are recorded earlier than S waves. These kind of questions are being asked by UP. P waves are primary waves. They are the faster. We have already covered this. Statement 2. In P waves, the individual particle vibrate and throw the direction of wave propagation, whereas in S wave, the particle vibrate up and down at right angle to the direction of wave propagation. I hope you remember in S wave, we have almost perpendicular motion. Energy is propagating and there is a almost we can say perpendicular motion with respect to vibration. Or the very first statement in this second statement is what that with the waves there is a backward, so there is backward, there is to and fro kind of wave propagation. So it's a simple question. Ahead, here you have practice. Examine how earthquakes are linked to the surface and examine how earthquakes are the structure and dynamics of earth in the complex. And here you have a second, that is the role of tectonic plates, fault and focus, epicenter, seismic waves, how the study of quakes or earthquake help in understanding earth's interior layers. Very tricky question. If you have attended that interior, only you will answer. I hope you enjoyed the session, the previous session, and in this session I have covered all the respective content prior to. And with respect to, do you have a content, do you have a basic thing zone? If you are exclusively watching this video only, haven't in that part, have did that. If you watch that video, question as well. So that's all for today. That's all for now. Have completed earthquake. I hope remember the catastrophism. The earthquake is taking place all of a sudden. So when the earthquake is all of a sudden, it will crust force. I remember mental convectional current which led to the in the rocks, which ultimately okay. So that's all about then